All right, everyone. Everyone having a good Modular Summit? Let's give a hand to Celestia for organizing this. Maven 11, this is amazing. And this is the last panel of the day, so everyone gets a trophy and a cookie for staying and watching us. Thank you. Mustafa, I've got a lot of questions for you about Celestia, both the history and how we've gone from lazy ledger to here and sort of what you expect from the future. But I was told, actually, that you, at one point, got arrested for hacking the CIA, and I've just got to get you to tell that story on stage. So give us the inside scoop. What's the history here?
Yeah, so we're starting straight with that. Okay. Yeah, I mean, I kind of like got into programming at an early age, and you know, like the first programming language I learned was PHP, and I started like thinking about ways that, you know, programmers could make mistakes in their code, and then I started like learning hacking naturally through that way. Like my first experience of a hack was when I was doing my math homework. I didn't have a calculator with me.
About how old were you when you were doing this?
Well, like this calculator thing, like was when I was like 11, and I don't have a calculator, but I need to do my math homework. So I searched online for like an online calculator, and I found this like shitty like Perl calculator on this maths professor's website. I think it was like University of Maryland, and it was like a text box. There was like a text box where you can like type in sums, and it would give you the result. So I was thinking, I wonder if he implemented this in the most basic way that a programmer would probably implement this, which is it was using Perl. So the way you would do it is you would take the user input and you would input it into a function called evaluate, and that basically evaluates Perl computer code. So not only could you type in like sums into this calculator, you could actually type in like computer code into this calculator, and the server would execute it. So you could actually hack the entire server through this exploitable calculator. And so I managed to like get access to this university server, you know, by typing computer commands in this calculator. And then I emailed the professor, and he tried to fix it, and then I found a way around it, and that was kind of like a very interesting experience for me. But then I kind of got like more involved in hacking when I started becoming more involved in like internet activism. I was involved with the groups like Anonymous and LulzSec. Anonymous was doing denial of service attacks against various entities that they were protesting against. So, for example, like when WikiLeaks, when PayPal and Visa and MasterCard blocked donations to WikiLeaks, they did a denial of service attack against PayPal and Visa and MasterCard to take them offline. And there was like thousands of people in the chat rooms kind of coordinating this. But for me, I thought that was kind of interesting, but it didn't really do much except for gain some media attention. So I decided, okay, why don't I actually try to hack something and like get information that could shed light on wrongdoing. So then I like found some technical people, and I noticed like a few people that were more technical than others, and I brought them into a private channel and kind of started a hacking group through there that eventually spun out into LulzSec.
So just to sum this up, by the way, the difference, Mustafa, between you and me when we're 11, if I didn't have a calculator, I just didn't do my homework and try to hack a new one out of the web. Yeah. And just to bring us up to the current time, and I think you're about 16 years old at this point, right? You're sort of casting around and looking for a righteous group that you can hack, and you settled on the CIA, which is that's a bold choice. Tell me, how does the CIA take to hackers? Are they, is that particularly welcomed?
Yeah, I mean, so the funny thing is, like, CIA was one of the many things that we kind of like attacked. But the funny thing is, like, the CIA wasn't even technically a hack. It was like denial of service attack. So it's like a denial of service attack. You're not actually getting confidential information. So we just took the CIA website offline, and that was like that's like a very basic thing. Like that's not even like the most. We did more advanced things than that. But like that was the thing that got the most attention. Or one of the things that got the most press attention, because like it was very embarrassing for the CIA to have their website taken offline. Yeah.
Did they thank you for this and say thanks for showing a vulnerability in their system, or were they a little less forgiving?
They thanked me in some very strange ways. That.
All right, we'll dig at that a little later. But I think this is a great story to tell because I sort of want to. I think there are a lot of very unique people in the crypto space, and I think the people who have made an enormous impact actually come at this not from a short-term money-making perspective, but from an ideological, how can we change the world perspective. So I think that's just important background for folks in the audience to understand. Now I want to actually move us forward a little bit in time and talk about Lazy Ledger, which was originally the name of Celestia and sort of the white paper and idea that launched this entire wave of modularity that's frankly blossomed into something super amazing that we're witnessing, this week in Paris. So tell us a little bit about how Lazy Ledger came to be and what did the early iterations of that modular idea look like?
Yeah, sure. So I've been interested in peer-to-peer systems for even before Bitcoin existed. Like I was interested in BitTorrent and peer-to-peer file sharing because I used to download stuff from the Pirate Bay, and it was very interesting to me that people could kind of just download stuff kind of permissionlessly. And the reason why I was so interested in peer-to-peer systems is because so many people would try to shut down their Pirate Bay, but to this day it's still online. So it's extremely censorship resistant, and that's thanks to technology like BitTorrent and DHTs. So then I learned about Bitcoin in 2010, 2011, and I was following that. And I was kind of following the research conversations going on. There was this IRC channel called Bitcoin Wizards, where people were discussing theoretical improvements to Bitcoin. And I noticed that there was a 1 megabyte block size limit in Bitcoin. And I was asking people, what are you going to do when it gets reached? And people weren't worried about it at the time. They were it would never get reached. But then it got hit pretty soon, in around 2013, 2012. And transaction fees became very expensive. And then the Bitcoin community started debating about how to fix that problem. And it kind of split into two camps. One camp wanted to increase the block size, and that camp spun out into Bitcoin Cash. And another camp wanted to use layer 2 technologies and payment channels and Lightning Network. And that was the Bitcoin camp that kind of prevailed the Bitcoin main network. But the reason why they didn't want to increase the block size was because the fundamental principle of blockchains and cryptocurrency is that end users should be able to fully verify and validate the chain. And if you increase the block size, it will make it more expensive for users to run full nodes. So then I started thinking about about this problem more, and then I started doing a PhD at UCL in 2016, focusing on layer 1 scaling. And at the time, people were talking about sharding. That was the most interesting scaling solution at the time. And I co-authored a paper called Chainspace, which was the first sharding protocol for smart contracts to be proposed. And this was around the time when Ethereum 2.0 was researching sharding. But the problem with all of these proposals were that they weren't dealing with the case where a shard goes bad. It was pretty much like a block size increase. The security model for those proposals was just increasing the block size. But there was no way to actually validate what the shards were doing. To fix that, you need to have fraud proofs and ZK proofs. And that's what rollups are doing. But at the time, the reason there was a missing problem to making fraud proofs and ZK proof work, which was the data availability problem, which was an unsolved problem at the time. And so I started doing more research into the data availability problem, and I co-authored this paper with Vitalik on how to scale data availability using data availability sampling. And then I realized that this is actually basically the core primitive that makes a blockchain work. A blockchain fundamentally at its core is basically a data availability layer and a consensus layer. So then I proposed Lazy Ledger, which was a kind of a paper that proposed a blockchain or a layer 1 chain that takes a layer 1 back to its core components. That's why it's called Lazy Ledger, because it's a lazy blockchain that does not do any computation. It only does consensus and data availability. And this was an idea I proposed about 3 months before optimistic rollups were proposed. So when optimistic rollups were proposed, everything kind of clicked together, because in my paper, I didn't really have a fully fleshed out execution model, and optimistic rollups provided that. So then it kind of made a lot of sense to actually build this, because rollup-centric roadmaps need a scalable data layer.
Yeah, I actually want to, get into the weeds of data availability. I think that's a word that many people understand kind of on a surface level, but it's such an important sort of roadblock in terms of realizing the grand vision that many great talks have actually laid out today. So I kind of want to actually go through and maybe just define sort of the basic components of a stack, which to me is the execution, the data availability, the settlement, and then the consensus. And can we focus on that data availability question? How would you, let's say there were a bunch of 5-year-olds in this audience, how would you explain the importance of that? And then why is solving data availability such a critical roadblock, not only for scaling base layer infrastructure, but for the cost of apps?
Yeah. So here's how I would explain it. When Bitcoin was created to solve what's called the double spend problem. And the double spend problem is a fundamental problem in creating digital cash, where if Alice has a certain amount of funds, how do you prevent Alice from spending the same funds twice? And the way that you prevent that is by having a blockchain that orders transactions. Because if Alice tries to spend their funds twice, then only the first transaction will go through, and the second transaction will be rejected. But in Bitcoin, this rule where only the first transaction can go through, or the rule where you can only spend funds that you actually have, is enshrined into every Bitcoin node. So that if you're on a full node and you receive a block that has an invalid transaction, your full node will execute every transaction and reject a block that contains any invalid transactions. So miners can't misbehave in that way. But the question that kind of led to Lazy Ledger was, and why data availability is so important is a thought experiment, which is, what if you created what is the simplest version of Bitcoin you can create? What if you had a version of Bitcoin with no rules about what transactions can go into the chain? Which means, imagine a version of Bitcoin where conflicting transactions, or transactions that double spend coins, are actually allowed to be on the chain. Well, how can that still be secure? How can that still prevent the double spending problem? Well, it's pretty easy. All you have to do is make sure that the clients simply ignore the second transaction, right? So technically, you don't need to enshrine computation or transaction validity rules to the chain itself. You can push that away to another layer, or you can push that away to a client-side node. So where the layer that you're pushing it to simply ignores those invalid transactions. And if you do that, then you're basically using the blockchain not for computation, but only for A, ordering, and B, data availability. And the reason why ordering is important is obvious, because you need to know which transaction came first to know which is the real transaction that actually got to spend those coins. And the reason why you need data availability is because you need to know the complete set. You need to know all the transactions that happened to know which one even came first in the first place. If not all of the transactions were published, only some of them, then you don't know if there's a missing transaction in the set that wasn't published that might have come before.
That makes sense. So I want to, understand from the perspective of, in kind of simple words, it's a lot of applications, they need data, they want to do it in a way that's cheap. And I want to start, painting a picture for those in the audience, if we solve this problem, what market structure changes are going to happen here? So, from a cost structure, my understanding for especially roll-ups and things like that is that data availability is a massive cost for them, right? And critically, it's a variable cost it doesn't get cheaper. It's not some fixed cost you can amortize across a whole bunch of users. It's actually something that is going to scale relative to the amount of transactions that happen. So I want to get a sense of, let's say, these apps start using Celestia for data availability, they massively lower their cost. What is the impact of this from a market structure standpoint? Do we see lots of new apps launching? Are there business models that are enabled with a lower cost of transactions that end up happening that have been precluded from happening before? Like, what are the first order implications of this?
Yeah, I mean, like the kind of like most immediate obvious implication is you have cheaper data availability leads to cheaper transaction fees. And I do think that a lot of usage of Web3 applications have been bottlenecked by the fact that transaction fees are too high. Like if we had cheap transaction fees, I would honestly genuinely think that we would see a lot more applications being deployed on Web3 and not just DeFi applications, but also, for example, to give an example, like this will be discussed in the gaming track tomorrow, but there's various on-chain games that are only practical with a high data throughput. Or even for financial applications, imagine you wanted to just use, like the original purpose of Bitcoin was to use it as a peer-to-peer cash system, but we don't have a single kind of widely used blockchain that is usable as a peer-to-peer cash system because of the transaction fees. So if we have like scalable DA, you have cheap transaction fees, then it can actually be used to what the original purpose of Bitcoin was, which is peer-to-peer cash, not just a store of value or an investment or something like that people hold because they think it will go up or trade on DEXs and so on and so forth. I think that's and I think the other kind of effect is we'll see a lot more applications become practical as a result of cheaper transaction fees, but also by having scalable DA and having on a modular blockchain stack, we'll be able to see a lot more experimentation with different execution environments where certain things that people wanted to do before are now possible. So some examples of that is that like various projects Manta, for example, have modified the EVM to add certain ZK or privacy-friendly opcodes that aren't possible on a standard EVM. Or for example, Curio have modified the EVM to create a 0.5 tick game engine to run a real-time strategy game on, which wouldn't be possible on a standard EVM. And historically, it wasn't possible to do that without deploying a new layer 1 if you wanted to deploy a new execution environment, which is a lot of overhead. To use like a Web2 analog, imagine if you had to have a physical server somewhere just to experiment with a new programming language or a new database. Today, that's not the case because you can just spin up a virtual server in the cloud on AWS or DigitalOcean. So you can think of rollups on a scalable DA layer as like virtual blockchains that enable people to experiment with different execution environments that unlock things and enable things that fundamentally weren't possible before.
I have a question for you, Mustafa, which is I've sort of found myself wondering as you were just discussing there. There's kind of this question that's a little fuzzy to me of, like, just as a hypothetical, with the proliferation of many different execution environments, now it's not just the EVM, many data availability layers, right? It used to be just Ethereum DA, but now we've got EigenDA and Celestia, Avail, other providers, and different choices for settlement and consensus as well. It's very possible in a very near time in the future that you could be using an application that's built on the Solana virtual machine, using Celestia as DA, but settling to Ethereum. And the question is, what chain are you on at that point? And where's the lock-in for these different environments?
Yeah, that's a good question. The whole point of modularity is to kind of shift away from a world where you have this tribalistic crypto environment, where it's like this chain versus that chain. It's like Ethereum versus Solana versus Avalanche, which is a very zero-sum mindset. And long term, it's important for chains to have a social moat, but long term, for crypto to go mainstream, ultimately users care about like usable products, not necessarily which chain that they're on, as long as the chain has basic unnecessary decentralization and security properties. And I think people right now kind of frame things like this app on this chain, like Uniswap on Polygon, Uniswap on Avalanche C chain. In the future, people won't be thinking in those kind of terms. People will be thinking, okay, this is the app, and it uses this stack underneath. Like when you use a when you interact with a website today on the web, you don't necessarily care too much about like what stack is using underneath. In many cases, you don't even know. Like when you go on Google, you don't know, is it using Linux, is it using FreeBSD? You don't necessarily know, as long as it provides the properties that you need.
Yeah. I want to actually do a little thought exercise here and imagine that you and I are sitting down, it's 5 years from now, and we're having this fireside, and I've got some questions for you to dust off the old crystal ball here, and I want to ask you about how things have played out during that time. What does the market structure look like, and what are some of the big changes that we might not be super obvious today? So, you know, we've heard from a lot of great projects today, these past couple of days, basically, new approaches to scaling infrastructure, new types of specific blockchains. I mean, what does the market structure sort of look like for the modular stack? I mean, are we going to live in a world of thousands of blockchains? Like, how many different general purpose rollups do we really need? Are these going to be across 2 or 3 trust environments? Is the multi-chain future really going to play out? Sorry, I can never just ask one question at a time here.
Yeah, like from an engineering perspective, when I kind of started Celestia, what I envisioned happening in a few years, and is basically already kind of materializing today, was a world where you can like go on the docs and you can click a roll-up as a service provider, and you can deploy a roll-up chain in 2 seconds, where you have a world where deploying a roll-up chain for your application is easier and more convenient than deploying a smart contract. And so there is a potential world where there's millions of interconnected chains that share security, similar to how today there's millions of web applications running. Like we've seen a very similar evolution in Web 2. 10, 15 years ago, if you wanted to create a new website or web application, you would use like an existing hosted service provider. Like you might use, I don't know, like Squarespace or Blogspot or WordPress, but that's very limiting. So now today, if you're an application developer and you wanted to deploy a new web application, it's like easier and more convenient to simply deploy a virtual machine on the cloud, on AWS or DigitalOcean, than using a shared hosting provider. And I think you'll see a very similar evolution in Web3, where shared web hosting providers are like analogous to shared smart contract platforms. And in the future, it might not seem obvious now, but like in the future, the obvious way to develop new applications will not be to deploy a smart contract on a shared smart contract environment that everyone shares, but to deploy a new roll-up chain, similar to how on Web 2 you deploy a new virtual machine for applications.
So, at the risk of asking potentially a spicy question here, I noticed that, so in this future sort of envisioned state of yours where we might have millions of roll-ups, I can't help but notice many of the roll-ups today, have these multi-billion-dollar valuations, a couple million roll-ups at a couple $1 billion each. You're starting to talk about some real numbers. So, I mean, how do you kind of see that shaking out? Is there consolidation in the future here? Or how many of these general purpose ones do we really need?
Yeah, we don't need, like, these millions of roll-ups won't have multi-billion-dollar valuations. Like, they won't all be like massive roll-ups. They might all be small applications, just like how there's different websites that offer small services or small applications. You might imagine like DAOs having their own roll-up chains, like similar to how organizations have their own Discord servers. They don't share the same Discord server as everyone else. They have their own namespace. You can imagine that DAOs might have, or projects might have their own roll-up chains that interoperate with other roll-up chains.
Understood. What about, one sort of theme, and maybe I'm reading a little bit too much into this and other folks think differently, is that I think, 5 years into bridges, we can all admit that it hasn't been as smooth as we thought it might have been at one point. And some of, especially like intent-based architecture, sort of points this idea, maybe we're not going to find out bridges as easily as we thought, and there'll kind of be a couple of different sort of trust zones or economic sort of zones. I mean, how do you kind of see it's very easy for me to imagine a world where there's apps that pick out, hey, I'd like this particular, EVM or execution environment in Celestia for DA or whatever. But how much do you actually see assets and data being interoperable between these different base chains?
Yeah, I mean, I think interoperability is, absolutely critical, and that's kind of like the reason why we're building Celestia as a shared security layer that can be used by rollups to interoperate without fragmenting their security, and that's why in the Cosmos ecosystem, we want to replace these committee-based IBC bridges, which have a heterogeneous security model that's fragment security, with a more homogeneous security model where roll-up share security and use fraud and ZK proofs, not committees. But it is the case that bridges today are very janky and don't have a good user experience. But I honestly think that the fundamental problems, like there's practical solutions to all these fundamental problems. It's just fundamentally a lot of it is just like an engineering slog that has to be, and a lot of missing pieces of infrastructure that just need to get built. So, like for example, if you take the fact that optimistic rollups, have a 7-day challenge period to withdraw from the rollup to the L1 or to another chain, that's solvable with atomic swaps. If you have an atomic swap to swap tokens, that's instantaneous, and that's what projects like Connex do, for example. And there's problems like you have to have multiple fee tokens to bridge across chains. That's also very solvable, and that's like Skip is solving those problems. It's just I think fundamentally it's just that we're very early. It's comparable to using the internet in the 90s. Like it was a very janky experience. You couldn't like stream video, for example. You have to connect. You have to manually click connect and then do a dial-up connection that takes like a minute to run. So I think it's just a matter of being early, and I think the challenges will be solved.
Yeah, I tend to agree with that, and that's kind of a nice segue into the next line of questioning here. And I don't know, do we have infrastructure to take questions from Mustafa from the audience? If I kind of want to maybe leave like 5 minutes at the end or so for that, but
yeah, raise your hand if you have any question. Feel free to interrupt.
Yeah, we can make it a true fireside here. But one thing that I'd love to get your opinion on, Mustafa, is how we eventually end up bringing more app builders into the space, because I think the thing that we all want to see is, especially in this next cycle, a couple apps that really take product market fit and bring millions of people on chain. I think that's the goal here. And one theme that's come up many times is sort of this chicken and egg problem in between apps and infrastructure, where we need good infrastructure to build good apps, but then the infrastructure also has to serve the apps that exist, and it's kind of like which comes first. So how do you kind of think about that problem, and then maybe we can talk about like how to bring more builders into the space?
Yeah, I mean, it's definitely like a complaint that people bring up, that it's a valid observation that there's a lot more infrastructure projects. It seems like there's a lot more infrastructure projects right now than actual applications. And that might seem wrong, but I actually think that's kind of fine in the interim, because like fundamentally, I think the reason why there's not a lot of Web3 developers is just that a lot of the things that seem easy to do with Web3 is actually not possible to do because of various either scalability or execution environment challenges. Like for example, take the fact that people want to build like the Uber in Web3. That's like a very stereotypical classic thing. People say, oh yeah, why isn't Uber on Web3? Like theoretically, it's possible. It's just like all the tools are very janky. Like it's impossible to do on an Ethereum L1. No one's going to pay $20 for a transaction fee. You need tooling to like share location data, right, in a decentralized way. That tooling is that tooling is being built. There's like libPTP to kind of like exchange messages in a decentralized way. Yeah, I just think it's just a matter of, so I think it is actually a good idea that there's a lot of infrastructure projects out there because to make the developer experience less janky and like more practical, to build the things that seem obvious in hindsight, like like Uber for Web3, but haven't been built. Yeah. Yeah,
completely agree with that sentiment. I think maybe one thing I'd also love to, frankly, just ask you as the the founder and developer of the Celestia ecosystem is like, what is the right way to do BD from your perspective? And there's a little bit like there's a couple of different approaches you could take, kind of like the bottoms-up ecosystem approach that several blockchain ecosystems have employed successfully, and then there's like a little bit more top-down and actually asking people to incentivizing builders and apps to come onto the platform. Like, how do you kind of think about building an ecosystem and doing BD within the context of Web3?
Yeah, I think it really depends on what you're building. If you're building something that's fundamentally new, and it's the only thing, like you're creating a new category, and you're the only product that provides that, then you probably don't need to do as much, direct BD, and a community will naturally form around that. But if you're doing something that's more competitive to things in an existing category, then you probably your main differentiator will probably be having a better BD team. So I really think it depends on the product, and I see like roll-up as a service providers doing a lot of BD to kind of attract roll-up developers onto it and so on and so forth. But really at Celestia, we do have a large community of people naturally building on Celestia. But we do have also BD team members trying to kind of like help people and explain the technology. But the way I see it is that we're just trying to create a distributed community, and we're trying to bootstrap a modular stack. Like, we're very happy to have competing DA layers on come and talk and kind of come to the summit, even though we're co-organizing it, because ultimately a modular stack is only credible if there's actually developers have choice in the stack. Like, people are only going to build if there's a lot of choice, so that they know that they're not locked into a specific ecosystem.
Yeah, understood. I think, it's been really inspiring to watch what Celestia has done and what you guys have achieved over a relatively short amount of time. And, I think one of the things that there's no shortage of love for in crypto is a little bit of drops of alpha. So, like, what can folks expect from Celestia? Not revealing anything you can't, obviously, but, like, what should people be looking out for over the coming months and year or so?
Yeah, I mean, like, the next milestone from here is mainnet. Currently planned in the fall of this year. And that's kind of like what we're kind of like heads down working on right now. We're trying to ship mainnet as soon as possible, because there's a lot of like people in the ecosystem that really need a DA layer, a scalable DA layer, and nothing exists right now. Soon we'll have EIP 4844, Polygon Avail, and so on and so forth. But there's literally like no DA layer right now that's actually usable as a kind of a DA layer that provides more than like 10 kilobytes of throughput. So it's like that's a thing that we really need to unblock people on. We also have like a lot of kind of like people joining the ecosystem and making announcements, integrating different parts of the stack. We recently had an integration with the OpStack, where we provided a data availability interface with the OpStack, so people can deploy OpStack rollups on Celestia, using Celestia as a DA and Ethereum as a settlement layer. And I think we'll be seeing a lot more of that and a lot more integrations like that, but with other stacks. Nice.
I've got my last question here, and then we can open it up to questions from the audience. But if you had to, I'm always interested to hear from sort of leaders in this space, like the two things that you find yourself thinking about the most, or maybe it's like a worry when you're falling asleep at night, like, man, I really just want to make sure that we get this done. Like, what are those, like, maybe two things for you at the current moment?
Well, I guess like from a very low level perspective, I'm very active on the engineering side of things, trying to make performance improvements where necessary. And I try to follow the developments, like people using Celestia, to see what the pain points and bottlenecks are with our testnets that we've done. But from a more high level perspective, the one thing that I kind of think about is to what extent in the long term, as crypto goes mainstream, will users kind of care about how decentralized a blockchain is, or to what extent a blockchain kind of conforms with the core values of crypto, which is decentralization, censorship resistant, verifiability. Because fundamentally, like from a user perspective, like if someone just created a centralized blockchain with like 2 validators, from a user experience perspective, it's very similar experience. So I kind of like, I think about like one fear I have is like the market will naturally just evolve to centralized solutions if users don't care. But so far, we haven't seen that to too much of an extent. Like, we haven't seen like an overly centralized L1 with like a proof of 10 validated proof of authority. That would be a very low-hanging fruit to build that could have like 1 billion TPS because it's not decentralized. So I think about like how communities or blockchains have social moat, and users care about using applications that they know or they believe are actually decentralized and censorship resistant. But I think about like to what extent that will hold true in the future, because like we're still very early. Like, you know, crypto hasn't really mainstream adoption. But I wonder, once we do reach mainstream adoption, if the ideals of crypto will ever become significantly diluted.
That's actually, I've actually asked myself a similar question. One thing that the way I've sort of phrased it to myself internally is, do you think there needs to be some sort of Overton window shift, right, in order for people to adopt? Like, you can't, so for instance, privacy, I feel like this comes up often in privacy discussions. I mean, in Web 2, right, I mean, the one thing that's been proven after, 20 some odd years is that users like don't really care that much about their privacy, and the vast majority will not take even very basic steps to protect it. And how are you going to build privacy-related infrastructure for people that simply do not demand or seem to value it with their actions almost at all? So do we need some kind of Overton window shift from a societal standpoint for some of these market structures to take place the way that we want? Or what do you think about that?
Yeah, I mean, like, we've seen Web 2 evolve in a very similar way. Like, like in the early days of the web, it was much more decentralized. People had their own blogs. They weren't sharing data with big tech. Now we have, people just using Facebook, most of the world using Facebook, sharing the data with everyone. But in Web 2, the interesting, like, unfortunately, like, humanity is very reactive and not proactive. Like, before 2011, most websites were just using HTTP. Like, you would log into Facebook. Like, this actually is something I saw, like, when I was in my hacking days. Like, the Tunisian government was capturing people's logins to Facebook because Facebook did not have HTTP enabled or enforced on the login page. But the thing that changed, the fundamental thing that changed, made people have a big push to encryption and encrypted messaging apps and HTTP apps and more privacy, was when Snowden leaked the NSA files in 2011 or 2010. And that was kind of like a big moment where there was like a massive difference before and after. Like, before, nothing was encrypted, basically. Like, no one cared about HTTPS. Like, all messaging apps were not encrypted. And after that, everything started, everything was basically encrypted by default. WhatsApp is now encrypted. Everything uses HTTPS. And then, there's been various scandals that actually has made Web 2 privacy the forefront of many people's mind. Like, the Cambridge Analytica scandal. People like Facebook has a huge perception problem with privacy. And ultimately, unfortunately, I think like it could end up similarly to Web 3. Like, right now, people don't care about financial privacy, but there probably will be, or like decentralization to some extent, but there probably will be a moment in the future where people learn that actually is very important, because there'll be like kind of like a Pearl Harbor of financial transaction privacy in the Web 3. Maybe someone is doing something very bad with all these on-chain transactions. Like Arkham Analytics is one of them, for example, de-anonymizing people based on their on-chain activity, for example.
Yeah, I tend to agree with that. Guys, we're in the final minutes here, and I want to open it up to the audience to see if they have anything that they want to ask Mustafa.
So there's a lot of DA solutions that are going to be live in the next year or two, which is really exciting. What do you think are the known unknowns around having these things live, around scaling them? Like, what do you think might potentially break, and the kind of open questions around the design space here?
Yeah, I think there's a few open questions. I think one of the biggest one is how do we get people to run light nodes? Because the only way to securely scale data availability is through having data availability sampling light nodes. And the more light nodes you have, the bigger the block size you can have. But historically, we've kind of over the past decade, we've had a model of Web3 where people just interact with these centralized RPC endpoints, which kind of defeats the whole point of Web3 anyway, because that's like a very Web2 model. You might as well just use Web2 because you're just interacting with a centralized database and trusting a trusted third party. So I think like we need to think about like ways to get more people to run light nodes, like maybe by having, I know like Mina is doing some great work on this. They have a browser version of their light node, so you can actually run the Mina node in your browser. So I think that's a good first step, and then we need to figure out how to integrate these light nodes into wallets by default. So for example, instead of MetaMask connecting to Infura, MetaMask should run an in-browser light node in the background and connect directly to the Ethereum peer-to-peer network. And I think that's a very important, like known unknown that people should think about. Like, how do we incentivize and get more people running wallets with light nodes?
Thanks for the talk. It was really enlightening to hear. So I think one difference between the last bear market and this one is the fragmentation of the ecosystem, that now we have so many different layer 2s going on that historians might call this the L2 wars that are going on now. So I was wondering, as someone creating a dApp, how do you choose the right L2 to build on? And what happens if the L2 you've built on fails? You might be able to retrieve account balances, but can you retrieve transaction history, reputation, all of those other aspects?
Yeah, it's a good question. I would actually say that, yeah, there's a lot of components in the modular stack. There's a lot of L2s, but I would actually say it's actually less fragmented than the previous bull markets, because in the previous bull markets, like it was way more fragmented because people were just building alternative layer 1 networks that did not collaborate with each other. At least with layer 2s, they can all coordinate with each other in the same stack, and one of the advantages, or what we're trying to achieve with the modular stack, is that you can replace components in the stack. So if you deploy something using a specific type of, if you deploy something on Arbitrum rollup, you could swap that out with the Optimism rollup, for example, or like you're not locked in to a specific vendor. That's like a very important component of the modular stack. I think that's more practical when you take into example of rollup app chains. Like if you want to develop a rollup app chain, let's say, I don't know, using the op stack, you don't and you choose Celestia as a DA. If Celestia fails, you can replace that Celestia with a different DA layer very easily because there's a common DA interface. So I wouldn't necessarily say it's fragmentation. I would say that there's more freedom of choice. And sometimes that's not necessarily always a good thing. Sometimes there's too much choice, and that's very difficult for developers to compare the trade-offs. But that's also an open problem, which is how do we get developers to understand the trade-offs between these different components and execution environments in the stack.
Thank you. Great talk, Mustafa and Mike. Thank you so much for all the details. I love that you touched the business development area, and I think it's great that you guys have a dedicated team inside the protocol. I would say that probably many of the projects, at least at the start, may not have this. So I was wondering, what are some learnings that you see in terms of like what works, what doesn't work, in terms of business development, or like maybe some advices that you would give to your builders, and maybe like what's your strategy? So you were saying like that would depend on of the product itself, but like in particular case for Celestia, as you are like closer and closer to the mainnet, like how would you, like what would be some strategies for growing the ecosystem that you would want to explore?
Yeah, I mean, I think like our kind of like overall long-term goal is to bootstrap a kind of like self-serving community. I think ideally we're trying to create a new category. So I think for any protocol, the success of any protocol should not depend on any kind of centralized BD team. Otherwise, it's not really a centralized. It's not really a decentralized protocol, you know. And so that's why we've kind of tried to create a community that a modular community that can kind of have a kind of like a mass or a network effect. And so if you think about other pieces of infrastructure with network effects, let's take AWS for example. AWS has a massive community of developers, and you don't need a centralized BD team of AWS because it has a network effect where lots of APIs integrate AWS. So it's very easy to use AWS because it has wide community support. And so for Celestia and other DA layers, there's a very similar process there, where we want to make sure that Celestia as a DA is supported by as many DA interfaces and roll-up frameworks as possible. You know, we started with the OpStack integration. We want to have the community develop more integrations so that Celestia, will be a default DA option for these, roll-up stacks. And eventually you have a community that kind of bootstraps itself, and you don't necessarily need a centralized BD team to kind of push it forward. Just Ethereum doesn't have a centralized BD team, for example.
Guys, I think unfortunately that is all the time that we have. Guys, everyone give it up for Mustafa. First of all, an excellent event. Thank you for the chat. This was really great.